Let's go through leak code 28. Find the index of the first occurrence in a string. For this question, it gives us our source string, haystack, and the target string, which is needle. And let's find the first index, which the needle appears in the haystack. So for example, set appears at index 0. So it returns 0. And the second example, we cannot find the needle in haystack. Previously, what we do this question, we can use something like the Robin cup, which is we call rolling hash, right? Rolling hash to do this. What we do is that do I have any? What we do for this is that we create a target hash code and have this one every time we generate for example, use a base 31 or whatever or 27, and every time we iterate the character, we have this number with my L multiplied by L minus A, and for example, if this one is from index 0 on the length to 3, 4, so power for this one, this is power 4, right? And plus 27 power 3 multiplied by E minus A, right? And when we go through the haystack, right? So we compose the first size of the which have the same size of length, right? To catch it to calculate its hash code. And if the hash code equals, right, we need to compare for this substring whether they equal or not. Because in hash there is hash collection collision. So when the two hash code equals, we cannot say those string is absolutely equal. So if we find it, for example, the same length have the same hash code, we need to compare these two substring first to see if they equal, right? If they equal, then we get this index. So we move the window for this rolling hash, right? So 1, 2, 3, 4, 5, 6, 1, 2. For example, we have a size like this, right? So then we if it does not equal, what we do is that we need to move this sliding window, right? So what we do is that we need to get rid of this, right? Get rid of this and have the rest hash code multiplied by 27 and plus the right part is this character, right? So that is for example, we have I, right? So I whatever we'll say this is I, right? Plus K, right? Plus K. So K is this length, right? This is character minus A, right? So we'll add the right part and then remove the left part. We're trying to see if this is slide window, the hash code equals the target. So I'm not going to write the rolling hash, but for this question, we're going to talk about another algorithm called Z algorithm. And so what does Z algorithm mean? Is that we have a string. We have a string, for example, like this. we create a for this string, right? We create a z array, which have the same length of this string. So, for example, if we have A, B, A, C, A, B, A, D, like this, right? E. So what does this one mean is that start from this index Z I mean is from this index I. What's the length? It's match the original string from the start 0. For the first one, we know it will match the whole length, but this one we are not. It's a information we may not need, right? So for this one, for the ZI0, normally we set this one as for example -1 or 0. Then we'll say this B does not match from the start A, right? So the maximum length is it match the prefix is 0, right? So also what we are going to do, let's use another color, right? Let's use so you'll say this A, right? Match this A. So we'll say the Z array has number 1, right? And C does not match from the start. So the Z array is 0, right? And this A match this A, right? So we'll see this A actually match this A, and this B matches this B, and this A matches this A, right? So we know from this index, it matches 3, length 3 from the start. So this number is 3, right? So I say this B does not match any from the start. So that is also 0. And this A is 1, right? D does not match. So this is 0, right? So this is the definition of the array means from any index. Any index, what's the length? It's matched from the start of the string. So for this question, what we need is that we put, for example, put a needle in front of the hay stack, right? So we compose a new string, and so in this case, we are trying to find from the index, for example, here, right? From if this is M, from index M, what is the earliest one which have the Z array greater than M, right? So I say this is length M. So we will say this is Zi, right? If we use a brute force way to calculate these numbers, for example, this is 3, right? Every time we go to this index, we trying to iterate again. It will be still O M multiplied by N, right? So it's not it's still not very efficient. So what is the algorithm actually let us to do is that for example, we have calculate this one, right? This one matches this part, right? So for example, we call this Z box. So in this case, any index in this box, right? They have a corresponding index here, right? So that means this Z, for example, this we call J, right? Zj should corresponding to this, for example, L, right? If they have the same number, same from this part, right? So if this character falling to this, right? So that means, but the thing is that we can only extend this z to this kind of range, right? Because after out of this, we call this z box. Out of this box, the rest may not be the same. So in that case, if that is say that we maintain a z box, left to right, and if we have, for example, the good thing is that we know this part, right? By the previous match, we know this part, they are equal, right? So that means that this kind of zx should be corresponding to this, right? So that means that if this zl is it does not exceed the previous z box, right? So we'll say this zj will be equal to zl. But the thing is that we didn't compare the character after out of the z box, right? So the thing is that what we are going to have this zj is the maximal, I would say minimal. This is zl, and this length, okay, this length, so that we are going to maintain. We'll say we have the left and the right is the left boundary and the right boundary of the z box, and we'll say in this case, what we can do is that if we have matched this part, right, then we can do brute force out of the box, right? Out of the box, so that we can maintain another, if there is match, for example, this is D, right? This is another D. We can maintain another Z box, right? So that it extend the range of the Z box. So that for every character inside the Z box, we can reuse what we already calculate to get the Z array, at least for the part from this index, for example, this kind of index to the right of the Z box. We'll not calculate again. We don't need to calculate again, right? So this is the Z algorithm, and I hope I can explain this clear. But the thing is that it saves us the calculations for this part. Okay, we don't need to iterate to do brute force again from this I to the right of the Z box. So the Z algorithm, the match will be all linear, right? So let's write code for this question if we use the Z box algorithm, right? So how can we write code for this, right? So we know let's have as we talk about Z array, we are going to find for every index what's the maximal length it match from the start of the string, right? So what we do is that we need to compose a new string, right? By putting the needle in front of the haystack. So let's change this to array. PR to cherry. We need to have, for example, let's have the length, right? Equals array dot length. And we have m equals needles dot length, okay? And let's, because we are going to maintain the left and the right of the Z box, right? So we have left and the right equals to 0. What we're going to do is that we need to generate a Z array equals new int n. Okay. So we'll say this is a new array's length, right? So it is needle plus haystack. So what we do is that for int I equals 1, I smaller than n, I plus plus, right? So we'll say actually what we do is that if we'll say if this I is smaller equal to right, right? That means we are in the Z box, right? In that case, we can extend the ZI, the length to from this I to right, right? So what we do is that if I smaller equal to right, okay, ZI equals so if that means if we have the I smaller than right? So that we just trying to find for example the related corresponding I minus L, right? I minus L. So does this one exceed the original right? So if we exceed the original right, we still should keep from here, right? So we cannot, because we don't know whether this match or not, right? So if this Z I minus L, the related, for example, this I, right? The right edge does not exceed this, right? So we'll say this ZI, we already calculate, right? So we'll have this kind of ZI equals ZI minus L. So in this case, we'll say this equals mass dot mean ZI minus L and the right edge is right minus I plus 1, right? Because what we want is the length, right? So what's the maximum length? It's not actually the index of this, right? It's not the index of this corresponding it's not the index of this. We were trying to get a number of the length. So we'll have the right index minus I plus 1, right? And in the other case that we just is the same as brute force. So what will say while I plus the I smaller than n, and also we have the so we'll say this part and this part, right? So we'll say if we match it here. We're trying to see whether this one can extend the right edge, whether it can extend, right? So you will say if this array zi equals array I plus zi, right? So if this character equals to this character, we can extend this right edge, right? So that is right for this part, right? And also we can for this kind of case, because it's out of the range, right? So we can also set the left of the box to be I, right? Left to be I, because we are going to create a new Z box. So left be here, right? And so this kind of, so if we have I, for example, move out of the Z box, we do the same thing, that we are going to update our I to our left to our I, right? So what we do is that while this one smaller than n, and the array zi equals array I plus zi, what we're going to do is that we have left equals I, right equals I plus zi, and we'll extend our zi, right? Plus. So this will be the code of the how we calculate the array, right? So what we do for this question, right? So actually this one, we can write this, right? Someone is like to write something like zi equals max dot max, right? 0 and this, right? So they are just the same formula. So depending on what you want. So line 8 to 10, we can write it like this as well. So what we do is that if we have I, the match index, right, greater or equal to m, and the I, if it's less, the greater the needle, right? You can write equals to needle as well. Greater, let's write a greater equal to, right? Because it may have something more than this to be matched, right? So let's write a greater equal than m, right? So we just return true. Return, we are going to find the first index, right? So that is I minus m. If we didn't match, right? So we just return -1, right? So this is a zip box algorithm. The time complexity is m plus n. Let's change this one to Python code as well. So let's say we are going to have our str equals, this is already str, okay. Let's call source equals, because in Python str it is untap, right? So let's have needle plus a stack. We'll have array was little this source. And actually we don't need anything here, right? So I'm going to have n m also left, right, because length source, length needle, and we maintain the Z box left and right bound index, right, 0. And we're going to have a Z array equals n, right? So what we do is for I in range from 1 to n, right? We're going to have the I. So let's say if we can also write if I smaller equal to r, right? And we can also write just another formula, max, right? 0 mean. So the mean is z I minus left, right? So and also right minus I plus 1, right? So we'll say while I plus the I smaller than n, and array the source the I equals source I plus the I, right? In this case, we are going to maintain the box left and the right. We have I left equals I, right equals I plus the I, right? And also we have the I plus equals the I plus 1, right? We can also write it like this, plus equal to 1. So we have the logic here, right? So if we match this, if I greater equal to m and the I greater equal to m, then we'll have we just return, right, the match index. That is because we append needle in front of I, so we'll just return I minus m. If in the end we didn't match, just return -1, right? So this will be the Python code. Needle is it should be this, not different like this. Okay.